Okay, so what we got here is question 4, and this is a really difficult 6 marker. So, a student is given two aqueous solutions, L and M, both contain iron salts, so we know they've got Fe in there. The student does a series of tests on the solution, so you can see they've added ammonia solution to both L and M. Which are both sorts of iron, so I don't know FeX, Fey, whatever. They've also added some sodium carbonate solution, which can normally tell you between Fe2 plus and 3 plus. They've added dilute nitric acid, which didn't do anything on its own, but then they added barium chloride, and we got a white precipitate with one and no change with the other. So you've got to know, what does the barium chloride test for? And then the silver nitrate test, what does that test for? Because that made a white precipitate with L but not with M. And then the question, the answer to the question needs to be broken down into identify all the precipitates formed in these tests. That's going to pick you up some marks. Explain why gas or effervescence was given off with L but not with M, and then give the ionic equation for all the reactions. So I'm going to start with L and go through all the tests in the column labeled observations with L and try and explain those. This is a very hard question. You might be happy you still come out with an A star if you can walk away with this one with 3 out of 6, because it's a very hard one and you need a lot of revision cards to revise all of these equations and learn all of this stuff to do with your transition metals and your complex ions. So first of all, here we're adding ammonia solution until it's in excess. But the reaction with both of them in excess didn't really do anything. They were both insoluble in excess. I think you'll find the excess ammonia is what you're adding that to find out if you've got copper in there, which we don't have. So we've got ammonia. We add it to iron 3 plus, and what we'll find is that it's quite a good acid with iron 3 plus, so it will donate those hydrogens and we'll get some ammonium ions formed, and you just balance this equation up. Now you might say, how do you know that it's iron 3 plus? Well, Fe3 plus compounds tend to have red brown colors, like rust, iron oxide, iron 3 oxide, and those type of things, whereas you get the green colors when you're dealing with iron with the Fe2 plus. So straight away that red brown precipitate makes me think, oh, I'm dealing with Fe3 plus. And what is that red brown precipitate? It's FeOH3 aqueous, or FeH2O3 OH3. It's not aqueous, it's going to be solid because it's a precipitate. Now, I haven't put all the symbols, but I should have put aqueous for some of these and solid brothers, but I'm being uber lazy. So you need this ionic equation, but you won't get the mark for this equation unless you also do the equation for L when it is reacted with sodium carbonate solution. So we're going to do that one now. Now, why did it give off effervescence? Why did it give off carbon dioxide, L, when reacted with sodium carbonate solution? This is because Fe3 plus is smaller than Fe2 plus, um, which formed the green precipitate with sodium carbonate, but L is Fe3 plus is smaller than Fe2 plus, so it has a higher charge density, i.e., a greater positive charge spread over the same area or a smaller area. So this means it's more polarizing to that carbonate ion, and it has the ability, therefore, to donate hydrogens more easily. So this is why Fe3 plus is a stronger acid, or has a stronger acid effect. Okay, so the equation for this, which you need to get both equations, one for the ammonia reaction and one for the carbonate reaction, to just score 1 mark for each of them. So you need both reactions for L for 1 mark, both ionic reactions for M. Actually, there's 3 reactions for each. We'll come on to the third one in a sec. So we want to do the same thing here. So FeH2O6 3 plus reacts with carbonate ions to form FeH2O3 OH3 plus carbon dioxide, and of course plus 3 water molecules. And so that is your reaction, your ionic equation. You should really put AQ next to anything that's ionic there. So next to the FeH2O6 3 plus as well, but there we go. And the water obviously is going to be a liquid. And the precipitate is the FeH2O3 OH3. And you get the same precipitate formed with ammonium or with carbonate solution. You get that same red-brown precipitate formed. And the identity of the precipitate is FeH2O3 OH3. Okay. Right, moving on. We've now got the third bit, so we know that L contains the 3 plus ion, and that was identified by its reaction with the carbonate, but also from the red-brown precipitate it forms. Um, Now, it had no change with the nitric acid and no change with barium chloride, which means that's normally the test for sulfate ions. So we're not dealing with iron 3 sulfate, but it does give a white precipitate with silver nitrate. And that means that it must contain chloride ions, because when you do the silver nitrate test and you get the white precipitate, it's normally chloride ions. So we're looking at Ag plus for the ionic equation, plus chloride ions, Cl minus, goes to AgCl with a solid symbol as it's a precipitate. And the Ag plus and the Cl minus are ionic, so they're going to be AQ. But again, writing all out all those, it's just too long for me at the moment. Right. So the identity of L, then, we've identified that it has an Fe3 plus ion, and we've identified that it has chloride ions. So its identity must be FeCl3, and that's a solution. That's aqueous, because it told us at the start the student is looking at two solutions, L and M, and they both contain iron salts. So our iron salt is FeCl3. Super duper duper. And that is really everything for L. So now what we're going to do, we're going to zing over and look at the results for M. And they're ever so slightly different for M. The precipitates are slightly different that are formed for M. So let's zip over and check those out now. So for M, what are our observations with M? Well, we need to write out the equations and why it didn't react with carbon dioxide. We kind of already explained that with the Fe2 plus 3 plus thing. So we got same thing at the start. We got Fe H2O6 with a 2 plus sign this time. Now we're adding ammonia. How did I know that this was the one with the 2 plus? Again, it's from the color precipitate, because Fe2 plus ions generally form green precipitates. And we've got the Fe2, and that's generally H2O4OH2, and they're insoluble in excess ammonia, and we get some ammonium ions formed. There we go. And that is that first equation. Again, anything with a positive or negative charge needs to have AQ next to it. And this is a solid precipitate, so it should have the solid symbol next to it. Again, I can't squeeze it all in here. Right, so that's the identity of the green precipitate, Fe H2O4OH2. Now let's do the reaction with carbonate solution. So we got CO2 minus with 3, that's the carbonate symbol. And this time it's not acidic enough that we polarize the carbonate enough that we get carbon dioxide. So we actually get FeCO3. And of course the carbonate is 2 minus and the Fe is 2 plus. So they come together in a 1-to-1 ratio, and we get 6 water molecules formed, which are the 6 ligands from the original reactant. Okay, so we got our two precipitates here. They're both green. One is FeCO3, one is FeH2O4OH2. Now, the Fe2 plus ion is not polarizing enough to form carbon dioxide, hence why we had no effervescence with observation M with the sodium carbonate solution. Okay, now we want to look at the fact that we did get a result, a white precipitate formed with barium chloride, and of course that is the sulfate ion test. So when you have Ba2 plus ions, they react with SO42 minus sulfate ions to form an insoluble white precipitate of barium sulfate. And so this tells us that what was the iron salt M? Okay, so the iron salt M must have been FeSO4. So we're looking at iron sulfate, and that must have been our original aqueous salt, FeSO4. There we go. That's going to get you the rest of the marks for this one. So quite a difficult question. I reckon if I was in my A-level exam and I peeled off 4 out of 6 on this, I'd be more than happy. But of course, we aim for perfection. We want to get 6 out of 6. And it's just one of those difficult A2 topics that you've got to revise inside and out using revision cards. Let's move on.